Hey guys, welcome to the Intermediate Algebra Exam 1 review. This is Professor Forsyth, and we're going to go through an actual Exam 1 review that you can find in your Hey guys, welcome to the Intermediate Algebra Exam 1 review. Hey guys, welcome to the Intermediate Algebra Exam 1 review. This is Professor Forsyth, and we're going to go through an actual Exam 1 review that you can find in your My Math Lab course together. So your questions will be very similar. They won't be exactly the same, but just kind of go through some questions. If you want to, have questions when we go through, you're welcome to ask. We'll just go ahead and get started. So, the first question, we're trying to find out whether an ordered pair is a solution of the equation. So, the equation is y equals 3x plus 7. And so the ordered pairs that we are going to determine if they're solutions, the first one is going to be 0, 7, and the next one is going to be 3, negative 16. Okay, so to check to see if an ordered pair is a solution, you want to plug in the ordered pair into the equation. So this is your x and y. So let's do the first one. So I'm going to call that ordered pair A. So we have y equals 3x plus 7. So we're going to plug in 7 in for y and 0 in for x. So we're going to have 7 equals 3 times 0 plus 7. So we're going to bring down the 7 equals 3 times 0 is 0 plus 7. And then 0 plus 7 is 7. So we have 7 equals 7. So this is a true statement. Yes, 7 does equal 7. So 0, 7 is a solution. Okay? Okay, so let's check the next one. So we have 3, negative 16. So again, this is our x coordinate and our y coordinate. And so we're going to plug in these values. Negative 16 goes in for y, and 3 goes in for x. So we'll just rewrite the equation. So we're going to have negative 16 equals 3 times 3 plus 7. Okay? So bring down that negative 16 equals 3 times 3 is 9 plus 7. 9 plus 7 is 16. So then we have negative 16 equals 16. That is not true. Negative 16 does not equal 16. So therefore, 3 negative 16 is not a solution. Okay? So again, you plug in the values and see if you get a true statement. So 7 does equal 7. We plug in 0, 7 into the equation. So 0, 7 is a solution. If we plug in 3, negative 16 into the equation, we get a false statement. This is not true. So 3, negative 16 is not a solution. Okay, let's go on to number 2. I think I dropped a marker. Yep. Okay. Alrighty. So, number 2. So we're going to find 5 solutions of this equation. And then we're going to make a table. So what I'm going to do, I am going to write the equation in the middle. And then we're going to have our solutions here as ordered pairs. Okay, so to make a table of values to find solutions of an equation, we're going to come up with our x values. And so we're going to start with negative 2 and then go all the way to positive 2. So we're going to do negative 2, negative 1, 0, 1, and 2. So we're going to plug in these x values into our equation n for x, and we're going to get its corresponding y value. So we're going to have x plus 7, but in this case, x is going to be negative 2. And then this value is going to give us our y coordinate. So negative 2 plus 7 is positive 5. Okay? So what this tells us is that one of our solutions for the equation is negative 2, comma, positive 5. And so all you have to do is plug in your x values into the equation to get its corresponding y value. So again, it's x plus 7 equals y. So in this case, -1 plus 7 equals y. So -1 plus 7 is going to be +6. And so that means that the other solution, another solution would be -1, +6. And so we're going to go through and do that for every x coordinate. So for x plus 7 here, it's going to be 0 plus 7. And then we have 1 plus 7, and then 2 plus 7. And then to fill in our table, 0 plus 7 is 7, 1 plus 7 is 8, 2 plus 7 is 9. So now our other solutions would be 0, 7, 1, 8, and then 2, 9. So these are our solutions. Okay? So to get your solutions, just make a table of values. Choose your x value. Make sure your equation is set equal to y, which this one already was set equal to y. So once your equation is set equal to y and your y is by itself, you plug in your x values to get its corresponding y value. Okay, let's look at number 3. Okay, so for number 3, we're going to use intercepts to graph the equation. So let's see. -x plus 2y equals 3. And then I'm going to graph my equation. I'll set that up in a second. Okay, so let's get our x intercept first. So to find the x-intercept, you need to set y equal to 0 and then solve for x. So let's take our equation, -x plus 2y equals 3. We're going to make y equal 0. So we're going to have -x plus 2 times 0 equals 3. So 2 times 0 is 0. So -x plus 0 equals 3. -x plus 0 is -x equals 3. And so we're going to make that be +x. So let's divide by -1. So -x divided by -1 is +x. Equals 3 divided by -1 is -3. So that's your x-intercept, is -3. If we want to write that as an ordered pair, it would be -3, 0. Because remember, the y was 0, and we found the x-intercept, the x-coordinate. So that's your x-intercept. Now, if we were to graph that, let's see. So I feel like I'm going to have a fraction, so I'm going to try to actually we'll graph that in a second. Let's do the other one. Okay, so now let's do the y-intercept. Okay, so to get the y-intercept, you set x equal to 0 and then solve for y. Okay, so let's take our equation again. -x plus 2y equals 3. And we're going to substitute 0 in for x. So we're going to have negative times 0 plus 2y equals 3. Negative times 0 is just 0, plus 2y equals 3. So 2y equals 3. I'll make sure I don't run out of space. Divide by 2 to solve for y. So y equals 3 over 2. Okay? And as an ordered pair, that y-intercept would be 0, comma, 3 over 2. Okay? And remember, 3 over 2 is the same thing as 1.5 or 1.5. So I'll just write that way. It's the same thing. Okay, so now let's graph these. So the x-intercept, -3, 0. So because I have fractions, let me number these like this. So this will be 1, 2, 3, -1, -2, -3. Okay, so the x-intercept is -3, 0. So I'm going to go to the x-axis and then go to -3 and plot my point. That's your x-intercept. That's where our line is going to cross the x-axis. Now, the y-intercept is 0, 3/2 or 0, 1.5. So we're going to go on the y-axis and go to 1.5. It's going to be right here. So now that we have 2 points, because all you need is 2 points to graph a line, connect the dots. Let's see if I can make a straight line. Ah, that's decent. And that is my graph of the equation using intercepts. Okay? All right, let's go to number 4. Okay, so number 4, it gives you a graph, and looks like this. Okay, so the graph looks like this. It's crossing here. It's a vertical line crossing there, and it's asking for the equation. Okay, so this is a vertical line. So one thing you want to remember is that vertical lines, they go straight up and down, and they're always going to be x equals whatever number. Okay, so it's x equals whatever number on the x-axis it crosses through. So where is it crossing the x-axis? At 8. So the equation is x equals 8. And so what that also means is that no matter where you are on the line, the x-coordinate will always be 8. So for example, this point's on the line, that's 8, 0. If I were to say, plot this point on the line, that's 8, 4. No matter where you go on the line, the x-coordinate will always be 8. So the equation is x equals 8. That's the equation of the line here that you see. And then just so you know, horizontal lines, let's say this was the line here. Horizontal lines are always y equals, because it's crossing the y-axis. And where is it crossing the y-axis? For this line, it's crossing it 2. So the equation would be y equals 2. And again, no matter where you go on the line, this would be 2, 2. 3, 4, 5. This would be 5, 2. This would be 0, 2. No matter where you are on the horizontal line, the y coordinate will always be 2. So your equation is just y equals 2 for this horizontal line. Okay, let's look at number 5. Okay, number 5, you're going to find the slope of the line that passes through 2 points. So we have -4, 6, and 3, 4. So we want to find the slope that passes through the 2 points. So we're going to use the slope formula. So the letter that we use to represent slope is m, because that comes from slope-intercept form. And so it's y2 minus y1 divided by x2 minus x1. So it's helpful to label your points. So the 1 to 2 just represents that we have 2 different points. So if this is like point number 1, this would be x1 and y1. And this is point number 2, that would be like x2 and y2. So if we label the points, we can easily see what we need to plug into our formula. So if we have x2 minus x1, we're going to have 4 minus 6 in the numerator. In the denominator, x2, which would be 3, minus x1, which is -4. Notice that this negative here, this minus, comes from the formula, and this -4 is my x1. So don't be careful with this, because the common mistake, people will just put 3 minus 4, but you need to include all the signs. Okay, so 4 minus 6 is -2 divided by 3 minus -4. We can change that to add the opposite, so that's just 3 plus 4, which is 7. So this is your slope, -2 over 7. Now it also asks you to determine whether the line rises, falls, is horizontal or vertical. So we have a negative slope, so that means it is falling from left to right. So the line falls. Okay? Positive slopes are rising, so positive slopes rise from left to right. Negative slopes fall from left to right. 0 slopes are horizontal. And then undefined slopes are vertical. All right. Okay. Okay, number 6, it asks us to find the slope of the graph. So I'm going to try to draw this as best as I can. Let's see. Drawing straight lines is so difficult. Okay, so we want to find the slope given a graph. So when you're given a graph, the best way to find the slope, you can just count your rise over run from one point to the other. And what that basically means, you are counting from one point to the other how much it moves up or down, divided by how much it moves left or right to get from one point to the next point. So on your exam and your review, you'll be able to kind of count better because it'll have grids, a grid paper. But here, let's count this. So let's say we want to go from this point to this point. So let's look at our rise. What's the change vertically? So we can go, this is technically here. So we can go 1, 2, 3, 4, 5, 6, 7, 8. It goes up 8. So that's a positive 8 for our rise. Now let's count the run, how much it goes from left to right. So to go from here to this point, we're going to go to the right. 1, 2, 3, 4. This is going to the right, that's a positive 4. So 8 divided by 4 equals 2. So the slope equals 2. Now what if we count it the other way? Would it still work? Let's see. Let's say we want to move from this point down to this point. So again, let's count the change in our y, or how we move up and down, divided by the change in our x values, or how we move left to right. So we would go, let's see, 1, 2, 3, 4, 5, 6, 7, 8. We went down 8, so that would be negative 8. And then we would go 1, 2, 3, 4. We go to the left 4, so that would be negative 4. And then guess what? Negative 8 divided by negative 4 is still positive 2. So it doesn't matter what direction you go in, you'll still get the same slope if you count, the right way. And again, just to show you, it's rising from left to right, so our slope is positive. So that's the way you can double check yourself to make sure you're good to go. Number 7. So find the slope of this line. Okay, so you could do this a couple of ways. One thing you could do is to remember that it's a horizontal line, and horizontal lines have a slope of 0. So that's just kind of from vocabulary and memorizing. So the slope of any horizontal line is 0. Now, you could also check by using the slope formula and plug in values. So you can pick 2 points on the line. So let's say this point is 0, 7. And then let's say this is 5, 7. So if you want to use the slope formula, just to double check. So let's use this and make this x1 and y1, and we'll make this one x2 and y2. So y2, we labeled it as 7 minus y1, 7, divided by x2, 5 minus x1, 0. So 7 minus 7 is 0, divided by 5 minus 0 is 5. So 0 divided by 5 is 0. So that verifies that we're correct by saying that this horizontal line has a slope of 0. Okay? Okay. Okay, number 8, we are going to determine whether the lines through each pair of points are parallel, perpendicular, or neither. So one pair of points is -10, -6, and -7, +4. And the other pair of points is -4, -2, and -1, +8. Okay, so things to remember about parallel perpendicular slopes. So, well, no, parallel lines rather. So parallel lines have equal slopes. The slopes are exactly the same. Perpendicular lines have, the slopes are negative reciprocals. Can you read that? Oh, almost went too far. Okay, negative reciprocals, okay, or opposite reciprocals. And then the way that I remember that is that I remember to flip and change the sign. So I'm sure we'll have to do that at some point on this review. So I'll just leave that there for now. Okay, so let's do this problem. So we first have to find the slope of each line that passes through each pair. So we'll start with this one. So I'm going to label this x1 and y1 and x2 and y2. So the slope formula is y2 minus y1 divided by x2 minus x1. So I labeled my y2 to be 4 minus y1 is -6 divided by x2, -7, minus x1, -10. So 4 minus -6. We'll change that to add the opposite. So 4 plus 6 is 10. Divided by -7 minus -10. Again, keep, change, flip. Add the opposite. So -7 plus 10 is +3. So the slope of this line that goes through this first pair is 10/3. So let's see what the slope of this line would be passing through this pair of points. So again, the slope formula is y2 minus y1 over x2 minus x1. So I'm going to label x1, y1, x2, y2. So y2 is 8 minus y1, -2, divided by x2, -1, minus x1, -4. So 8 minus -2, add the opposite. 8 plus 2 is 10 divided by -1 minus -4. Again, change it to add the opposite. -1 plus 4 is +3. So let's compare these slopes. 10 over 3, 10 over 3. They are equal. They're the same number. So these 2 points, these pair of points make up. So the line that passes through these 2 points and the line that passes through these 2 points are parallel lines. Okay, so the answer there would be parallel because they have the same slope. Okay. I was hoping I could keep this there. I know we're going to use that again, but not until later. So I will have to erase it so I can have room for the next problem. Okay, number 9, we're going to start off with this given equation, 7x minus 4y equals 28. And number 9 says begin by solving the linear equation for y. This will put the equation in slope-intercept form. So let's first do that. We're going to solve this equation for y. So we want to get y by itself. So to start getting y by itself, we want to get the term that has y by itself. So that means we need to move this 7x. So I want to get rid of 7x. I want this to go away. So I want to subtract 7x because 7x minus 7x would be no x. That'll be gone. But if I subtract 7x from the left, I have to subtract it from the right as well. On the right hand side of the equal sign. That's the equal sign there. Can't really see that, but that's okay. Okay, so that cancels out. I'm going to bring down my -4y equals. So they mentioned the slope-intercept form. Let's write down what that is so we can know what we want. Running out of space. Okay, slope-intercept form. Y equals mx plus b. That is slope-intercept form. Okay? And so it gives you 2 very important pieces of information. The b is your y-intercept. And the m is the slope. That's why it's called slope-intercept form. Okay, so that means when we're writing the right-hand side of this equation, I want to put -7x first because I want the x term to be first. So I'm going to say -7x, then bring down plus 28 because I want it to be in slope-intercept form. And again, it's y equals, so I want to get y by itself. So now I want to get rid of this -4 that's being multiplied by the y. So I'm going to divide by -4 everywhere in the equation. So -4y divided by -4, the -4's cancel out, and I have y equals -7x divided by -4 would be positive 7x over 4. And then 28 divided by -4 is going to be -7. And just so we can see very clearly what the coefficient is here, let's write that as y equals 7 over 4 x minus 7. Okay, so now we have the equation in slope-intercept form. And then it says to find the slope and then find the y-intercept. So when you have it in slope-intercept form, it's really cool because all you have to do is like look at it. So the coefficient of the x term, that's your slope. So the slope is 7 over 4. The constant at the end is your y-intercept. So the y-intercept is your b, which in this case is negative 7. So the slope is 7 over 4, and the y-intercept is negative 7. Okay, so now we're going to use slope-intercept form to graph an equation. So I'm going to leave that there on the right. Let's now graph an equation. And actually, I'm going to erase this. So I'm going to do something else there. This is number 10. Okay, so number 10, we're going to graph y equals 1/2 x minus 3 using the slope and the y-intercept. So slope-intercept form is great for graphing because, again, we can use these two very important pieces of information to graph the equation of a line. So we're going to start with the y-intercept. So we're going to begin by plotting the y-intercept, and then we're going to move with the slope. Okay, so let me draw a little plane here. So in this case, what is your y-intercept? B. B in this case equals negative 3. So we're going to begin by going to negative 3 on the y-axis. So there we go. That's the y-axis there. Then we're going to move with the slope. So that's your m. M in this case is 1/2. And remember, slope is rise over run. So beginning with B, so we plotted B, our y-intercept, which is negative 3, and then we're going to move with the slope. So if the slope is 1 over 2, we're going to go up 1 and to the right 2. Up 1 to the right 2. And you can do this as many times as you want. You could even do it backwards. If you go up 1 to the right 2, you could go down 1 and back 2. Because that's still positive 1 over 2. So you could go down 1 and to the left 2. Down 1 to the left 2. I completely missed those points, but you guys get the point. So this is your equation passing through these points. And there you go. So remember, begin with the B, the y-intercept, and then you move with the m, your slope. And if it's in slope-intercept form, you can graph just that quickly using that information. So now we're going to graph another equation using slope-intercept form, but it's not already in slope-intercept form. So we got to do a few more steps. So this is number 11. 5x plus 8y equals 40. Okay, so we want to first put the equation in slope-intercept form. So that means we need to solve for y. So we'll start that process by subtracting 5x from both sides of the equation. So on the left side of the equal sign, 5x minus 5x cancels out. I have 8y equals, I want to put negative 5x first because I want this to be in slope-intercept form. Then bring down that positive 40. Next, to solve for y, we're going to divide by 8 on both sides of the equation. So So we have y equals negative 5 over 8 x plus 40 divided by 8 is 5. So this is slope-intercept form. Now we're going to identify the slope. So the slope, which is m in slope-intercept form, here is going to be negative 5 over 8. Then the problem asks you to identify the y-intercept, which is b. So in this case, that is positive 5. And then finally, it asks for you to graph using the slope and the y-intercept. So we're going to begin with the b, which is positive 5. So that's 5 on the y-axis. 1, 2, 3, 4, 5. And then we're going to move with the slope, which is the m. So it's negative 5 over 8. That's going to tell you how you rise over run. So we're going to go down 5. 1, 2, 3, 4, 5. And go to the right 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we will connect the dots. Oh, I did a better job. And then that is my graph of the equation that we got into slope-intercept form to then graph on the coordinate plane. Okay, so now we're going to start using another formula called point-slope form. This is number 12. Okay, so it says to write the point slope form of the equation of the line satisfying the given conditions. So it passes through -3, -5, and 2, 5. Okay, and then let's put point slope form. Where do I have the most room? I'll try to fit it right here. So point slope form is y minus y1 equals m times x minus x1. Okay, you can see that. Okay, so x1 and y1 come from a given point on the line, and then m is the slope of that line. So to use point slope form, you need a point and you need the slope. Those are the two things you need to use point slope form. So all we have right now are 2 points. So we have 2 points we could use. So we've got a point. We need the slope. So let's find the slope of the line passing through these 2 points. So we're going to use our slope formula, y2 minus y1 over x2 minus x1. And then let's label our points so we can know what we want to plug in. I didn't mean to call that x2. I could have called that x2. That would have been okay. But just to be consistent, I'm going to call this x1 and y1, x2 and y2. Okay, so let's plug in our values. So y2, 5 minus y1, which is -5, divided by x2, 2 minus x1, negative 3. So 5 minus negative 5 changes to 5 plus 5, which is 10, divided by 2 minus negative 3 changes to 2 plus positive 3, which is 5. And then 10 divided by 5 is 2. So 2 is the slope of the line that we are going to write an equation for. So we've got the slope, and then we have 2 points. So all we have to do is choose one of the points and plug them into point slope form. So I'm going to rewrite point slope form here. And just since I already have them labeled as x1 and y1, I'm going to use that point. But you don't have to use that point. You could use the second point if you want to. It does not matter. But just because I already labeled it, I'm going to use that first point. And then this is m. So I have y minus y1 negative 5 equals m, which is 2 times x minus x1, which is negative 3. Okay, so this would be point slope form, or we could even clean this up a little bit. Y minus negative 5 changes to y plus 5 equals 2 times x plus 3. So, and the exam does ask you to write it in point slope form. So that would be point slope form. Then it asks you to write it in slope intercept form. So we need to solve this for y. So let's distribute the 2 on the right. So 2 times x is 2x. 2 times 3 is positive 6. And then we have y plus 5 on the left. And then to get y by itself, I'm going to subtract 5 on both sides of the equal sign. So y equals 2x, and then 6 minus 5 is positive 1. So this would be slope intercept form. So on your test, it's going to ask you to find both. So we've got point slope form here, and then we just solved for y to convert it into slope intercept form. All right. So we're going to continue using point slope form to get equations. And it's just going to determine, what we do is going to determine on what information is given to us. I'm going to leave this over here because that'll be useful for us when we solve this next problem. And I know y'all, sorry if I'm sniffing. You know, this is live in effect, all right? So sorry about that. This weather has been killing me. Okay, so oh, sorry about that, guys. Okay, so the next one, we just did 12. Let's do 13. Okay, 13. So we have different conditions. So it's passing through. This is my shorthand for through. 9, negative 5. And then it's perpendicular to the equation y equals 1 over 5x plus 4. Okay, and it says to write an equation in point slope form, and then we're going to write it into slope intercept form. So remember this over here. This is point slope form. Right here. I don't know what this is. Okay. This is point slope form. These are the two things we need to use point slope form. We have a point, so we can check that off here. We have a point, and we don't have a slope just immediately given to us, but we have information here that's going to help us with finding the slope that we need to use for our equation of our line. So the equation of the line we're going to write is perpendicular to this equation of the line. So the slope of this line is 1 over 5. Okay, that's the given slope that they're giving us to help us get the slope that we need. That's perpendicular to this. So perpendicular slope, so the slope of the perpendicular line would need to be the negative reciprocal of 1 over 5. So we would need to flip it. So that would be 5 over 1. And then change the sign. So it'll be positive, it goes to negative. So negative 5 over 1 is really just negative 5. So the slope of the line that we want to use is negative 5. This is the one that we want. So now we have a point, and now we have a slope. So now we can use point slope form. So it's y minus y1 equals m times x minus x1. So this is my x1 and y1, and this is my m. So we have y minus y1, which is negative 5, equals m, for us is negative 5, times x minus x1, which is 9. So that's going to be y plus 5 equals, and then we can just leave it as this, negative 5 times x minus 9, and this would be our point slope form. That's point slope. Now, to get slope intercept form, we need to set it equal to y. So to start that process, so now to get slope intercept form, let's distribute the negative 5. So negative 5 times x is negative 5x. Negative 5 times negative 9 is positive 45. Bring down that y plus 5 equals, and then to get y by itself, I'm going to subtract 5 on both sides. So y equals negative 5x, and then 45 minus 5 is positive 40. So this is slope intercept form. Okay? All right. Okay, let's keep the party going. So I'm going to leave this here because it's very similar, but not the same. And this is 14. So the equation of the line that we're going to write passes through negative 1, 4, and it is parallel to the line x minus 2y equals 7. Ooh, sorry. Okay, so now, again, to use point slope form, you need a point and a slope. This is what we have to work with. We do have a point. We do not have a slope just yet. But what we do know is that the slope that we need, that line slope, is going to be parallel to this line slope. Let's figure out what this line slope is and use that information. So we want to put this in slope intercept form to help us identify what the slope of this line is. So to start that process, So put in slope intercept form. So we're going to subtract x on both sides, and then we'll have negative 2y equals negative x plus 7. And then to solve for y, we're going to divide by negative 2. So y equals negative divided by negative is a positive 1 over 2 x, then minus 7 over 2. Okay, so the info that we need is just the slope. So the slope of the given line is 1/2. Our slope is parallel to this slope, so that means that the slopes will be equal. So the slope that we need is also 1/2 because they have equal slopes. Parallel lines have equal slopes. Okay, so now I already have my point, and now I have a slope. So then I can use point slope form. So this is x1 and y1. So y minus y1, which is 4, equals m. We're going to use 1/2 times x minus x1, which is negative 1. So y minus 4 equals 1/2 times x plus 1 would be point slope form. Now to get slope intercept form, we need to solve for y. So let's distribute this 1/2. So I'm going to have y minus 4 equals 1/2 x plus 1/2 times 1 is 1/2. And then to get y by itself, we're going to add 4. Make sure I don't get off the screen. Y equals 1/2 x plus 1/2 plus 4. Now, let's do this over here on the side. 1/2 plus 4. Let's change that to get common denominators. So we want it to have a denominator of 2. So that's going to be 8 over 2, because 8 over 2 also equals 4. Okay? So now that I have common denominators, I can add the numerators and keep that denominator the same. So it's 9 over 2. So my slope intercept form, I'll do it over here. Slope intercept form is going to be y equals 1/2 x plus 9 over 2. Okay? Okay. How are we feeling out there? Okay. Remember, you can always ask questions. Okay. We're going to move on from writing equations right now. Okay. Number 15 says to find the intersection of the sets. So the first set is K, M, and N. Intersection of an empty set. Okay, so this means intersection. That means we are talking about what the two sets have in common. Okay? What the sets have in common, the same, any overlap. So right now, this set is K, M, and N. Those are the elements in this set. And this set has nothing in there. So do these two have anything in common? No, they do not. So the solution is what we called an empty set. It doesn't have anything in common. Okay? And that's it. All right. Now I'm going to I'll do 16 right here. Okay. 16 says find the union. So the first set is 5, 7, 8, 9. And then we have 3, 5, 7. This means union. So find the union of the sets means that we want to include everything. So everything in this set and everything in this set would be a part of the union of the two sets. So we're going to just list them. Put little curly brackets on the outside, and let's list from smallest to largest. So this one has a 3. It does not matter if this set doesn't have a 3 because the union means we want to include everything that we see. So 3 would be a part of the union. This one has a 5. That one has a 5. You don't need to list it twice. Just list it one time. So the next one would be 7. And that one happens to have a 7 as well. As long as just one of them had a 7, we would include it. 8 is in this one. It doesn't matter if it's not in that one because we're talking about the union. 9 is in this set. It's not over here, but it doesn't matter. It's a part of the union. And that's it. So this would be the union of these two sets. Just to make sure you understand what intersection is, we're going to just make up a problem. So this is an extra example here. So we have those same sets, 5, 7, 8, and 9. We want to find the intersection between that set and then 3, 5, and 7. So we only want what they have in common. So for example, this set has a 3, this one does not. So 3 would not be in the intersection. Okay? This one has a 5 and that one has a 5. So that would be a part of our new set. This one has a 7. This one also has a 7. So that would be in the set. But this has an 8. That one does not have an 8. So that is not a part of our set. This one has a 9. This does not. So the only two elements that overlap are 5 and 7. So that would be the intersection. That's the difference between intersection and union. Okay? Union means everything. Intersection means where they overlap. Number 17. Okay, So it says solve the inequality and graph the solution set on a number line, and then we're going to write it in interval notation. So we want to solve for x and get x by itself. So within this compound inequality, let's get this term by itself. So let's start by adding 1 in the middle, and therefore to keep it all balanced, we have to add 1 on the left and the right. So now here, -7 plus 1 is -6, which is less than 3x, which is less than or equal to 2 plus 1 is 3. And then now we want to get x by itself, so we're going to divide by 3 everywhere, because that will cancel out the 3 and give us x in the middle. -6 divided by 3 is -2, which is less than x, which is less than or equal to 3 divided by 3, which is 1. So let's graph that. So we have -2 and 1. And this is telling us that x is between -2 and 1. But we are not including -2, so we're going to use a bracket here. But we are including 1 because it's less than or equal to. Wait, did I call this a bracket? This is a parentheses. This is not a bracket. That's a parentheses. Here we're going to use a bracket. Okay? So remember that we use parentheses for less than or greater than. We use brackets for less than or equal to, or greater than or equal to. Okay, you can't see that. Let me try that again. Alright, parentheses for less than or greater than. Here we go. Brackets for less than or equal to, greater than or equal to. That's better. Okay. Alright, so x is between these values. That's how it will look on a number line. Now the cool thing about a number line to me is that it makes writing interval notation easier because it almost mirrors how it looks on the number line. So a few things to remember about interval notation. So the far left, if you just keep going, that's why this is an arrow. This is going on and on and on and on to infinity. To the left, it's going on and on and on to negative infinity. Okay? So that's just something for you to know. But for here, we want to write this interval that's shaded in interval notation. So we always go left to right. So starting from the left, it starts at -2, but we're going to use a parentheses because it's just less than. Okay? So parentheses -2 all the way to +1, but it's less than or equal to, so we use a bracket. So this is the inequality, this is the number line solution, this is the interval notation. Okay. Okay. 18, we've got 3x is greater than 7x minus 28, and 4x is greater than 2x plus 6. Okay, so let's start by solving each individual inequality. So this first one, we want to put all of our x terms on one side of the inequality. So I'm going to subtract 7x. So then I'm going to have 3x minus 7x is negative 4x, which is greater than negative 28. And then I want to get x by itself, so I'm going to divide by negative 4. Now remember, when you divide or multiply by a negative when you're solving an inequality, you have to flip the sign. So this greater than becomes less than. So then we have x is less than negative 28 divided by negative 4 is positive 7. Okay, now let's take care of this inequality over here. So I'm going to subtract 2x because I want to get all of my x terms on one side of the inequality. So 4x minus 2x is 2x, which is greater than, bring down that positive 6. And then now to get x by itself, I'm going to divide by 2. So x is greater than 6 divided by 2, which is 3. Okay, so this is an and inequality. All right, so that means that we want the intersection. Where they intersect. Okay, and so we want to see where our graphs or our solutions overlap. So let's graph them and see where that is. So I've got 3 and 7, so I'll put the 3 on the left of the 7. That's where it would go on the number line. So x is less than 7. So this 7, we're going to use the parentheses, and all the values less than 7 are to the left, so it's shading in that direction. Now, x is greater than 3. So here's 3. We're going to use the parentheses, and all the values greater than 3 are going to be in this direction. Okay, but this is an and compound inequality, so we want to see where they overlap. Where is it overlapping? Right here. Okay, so it's overlapping here between 3 and 7 with parentheses on both ends, but it's in between 3 and 7. So this is my solution here. And now in interval notation, again, you can look at it starting from the very left of our shaded region. That's at 3 with parentheses, and it's going all the way to 7 with parentheses. So this is the graph of the solution, and this is the interval notation of the solution. Okay, so this is my answer here. Okay, let's do another. It's going to be an or compound inequality. Let's see how or differs from and. How do you all think it's different? Let's see. I bet you guys know. And I'll just leave that there. That's helpful. Okay. All right, so 19, we've got 3x plus 3 is less than or equal to 9, or 5x minus 8 is greater than or equal to 12. Got a little excited there. Let me bring that down a little bit so you guys can see it. Let's see, 5x minus 8 is greater than or equal to 12. That's better. Okay, so solve them each individually. So let's subtract 3 on both sides to get x by itself. So we first get the term with x by itself. So we have 3x is less than or equal to 9 minus 3 is 6. And then we're going to divide by 3 to get x by itself. So x is less than or equal to 6 divided by 3, which is 2. Let's just leave that there. Now let's go over here. So we're going to get 5x by itself. So let's add 8 to both sides. So 5x is greater than or equal to 12 plus 8 is 20. And then to get x by itself, we're going to divide by 5. So x is greater than or equal to 20 divided by 5, which is 4. Okay, so now let's see how these will look on a number line. So this is an OR inequality. So OR is asking for the union. So we want to include it all, everything. Okay, include it all. Okay, so we've got 2 and 4. So x is less than or equal to 2. So we're going to use a bracket. And then we're going to mark it right here and shade to the left because that's where the values less than 2 can be found. Now let's look at x is greater than or equal to 4. So again, we're going to use a bracket. We're going to face this direction because the values greater than 4 are over there. Okay, so this is an OR compound inequality, so we want to include this and this for our solution. So this graph would be our solution. Now let's talk about it in interval notation. So we always go from left to right. So we actually have 2 intervals. This is an interval here, and there's like a space, and then another interval. So remember that the most left part of the number line is considered to be negative infinity. So it's going on and on and on forever to negative infinity. And on the right, it's going on and on and on forever to positive, or just infinity. So let's express these intervals here. So this one here, if we start from the left, it starts at negative infinity. And you always use parentheses when you're talking about infinity because it just keeps going on and on and on forever. The whole idea, there's no, definite ending. So we never want to use a bracket for infinity. So it starts at negative infinity and it's going all the way to 2 with a bracket. Now you want to also include, so we're going to use the union symbol to say the union of this interval with this interval. So this one, starting from the left, it starts at 4 with a bracket, and then we're going to go all the way to infinity. And remember, we always use parentheses with infinity. So this is interval notation. This is the solution on a number line. And these are the 2 solutions separately as inequalities. So x is less than or equal to 2, or x is greater than or equal to 4. And that just means that either one of those, either or, would work to be a solution for this compound inequality. All right. Okay. Let's have some fun with some absolute value. I'll make this more. Okay. So, number 20. Okay, so we have the absolute value of 5x minus 8 plus 3 equals 8. So remember, the absolute value of something represents the distance that is from 0. Okay? So to start solving this in particular, we have to get the absolute value part isolated by itself. So we need to get him by itself and move this plus 3. Move him over here. So we want to start by subtracting 3. Do that first. So now I have the absolute value of 5x minus 8 equals 8 minus 3 is 5. Okay? Now we're ready to solve it. So the absolute value of 5x minus 8 equals 5. So just something to keep in mind. Let's see. The absolute value of x equals 5, for example. Did it again. Okay. Okay. So the absolute value of x equals 5. So what could x possibly be? So if we're thinking about a number line, this is 0. Say this is 5, this is negative 5. If I were to count the distance from positive 5 to 0, that would be 1, 2, 3, 4, 5. If I were to count the distance from negative 5 to 0, that would be 1, 2, 3, 4, 5. So the absolute value of 5 equals 5, and the absolute value of negative 5 equals 5. Okay? So I'm showing that to show you and explain why we're going to solve these absolute value equations the way that we do. So what this is saying is that this value in this absolute value, 5x minus 8, so I dropped the absolute value symbols, that could equal 8 and work. It could also, 5x minus 8 could also equal negative 5. Because of this type of, oh, you can't see that. Why do I keep doing that? Let me try that again. Okay, so what I said over here, I said the absolute value of 5 equals 5, and the absolute value of negative 5 also equals 5 because of this kind of scenario here. So from 5 to 0 is 5 units. From negative 5 to 0 is also 5 units. So when we're solving this, we drop the absolute value signs, set it equal to 5, and then we drop the absolute value signs and set it equal to the opposite, or negative 5. Then we just solve them individually. So for the first one, we'll add 8 to both sides. So then we have 5x equals 5 plus 8, which is 12. Then divide by 5 on both sides, so x equals 12 over 5. Okay, not 12. 5 plus 8 is 13. I did that on purpose. Don't you love when teachers say that? 5 plus 8 is 13. Divide by 5, we have 13 over 5. Okay. Now let's solve this one. So we're going to add 8 again to both sides. So we have 5x equals negative 5 plus 8 is going to be positive 3. And then divide by 5 on both sides. So x equals 3 over 5. Okay? And so those are our two solutions. X equals 13 over 5, and x equals 3 over 5. Okay, let's look at another one. Okay, 21. The absolute value of 6x minus 4 equals the absolute value of 2x plus 13. So the way that we solve these is very similar to the previous problem. So we drop the absolute value. So we have 6x minus 4 equals, we can drop the absolute value and just rewrite what's inside. So we're going to solve that. And then we drop the absolute value on the left and set it equal to the opposite of what we have on the right. So notice that I kept this expression in parentheses because I need to distribute that negative. I don't want to only negate the 2x because then that wouldn't be the opposite of this entire expression here. So this equation, let's solve for x. So I'm going to subtract 2x to move my x terms to the left. So 6x minus 2x is 4x minus 4 equals 13. And then to solve for x, I'm going to add 4 to both sides. So 4x equals 13 plus 4 is 17. And then to solve for x, I'm going to divide by 4. So finally, x equals 17 divided by 4. So that's one solution there. Over here now, I need to distribute the negative before I start moving terms across the equal sign. So I'm going to have 6x minus 4 equals negative times 2x is negative 2x. Negative times 13 is negative 13. And now I'm going to add 2x to move it to the other side. So I have 6x plus 2x is 8x. Bring down that minus 4 equals negative 13. And then now to get 8x by itself, I'm going to add 4 to both sides. So we have 8x equals negative 13 plus 4 is negative 9. And then to get x by itself, I'm going to divide by 8. So x equals negative 9 divided by 8. So these are my two solutions. X equals 17 over 4 and x equals negative 9 over 8. Okay. Okay, 22. We have 4 times the absolute value of y plus 8 equals 20. Okay, so before we can start doing our two equations, we need to get the absolute value by itself. So we have 4 times this absolute value, so we want to divide by 4. So then 4 divided by 4 cancels out, and I have the absolute value of y plus 8 equals 20 divided by 4 is 5. So now, ignore that. So now we're ready to solve this. So we make our two equations. So drop the absolute value. Y plus 8 equals 5. And then drop the absolute value signs equals negative 5. And then we're going to solve each one for y. So here to solve for y, I'm going to subtract 8. So y equals 5 minus 8, which is negative 3. So that's one solution. And here I'm going to subtract 8 again. But on this one, I'm going to get y equals negative 5 minus 8, which is negative 13. So my two solutions are y equals negative 3 and y equals negative 13. Okay, so now we're going to conclude with inequalities, graphing linear inequalities. And then if you have any other questions, that's going to be it. Remember, you can always look back at this anytime as you're preparing for your test, and you can do your test review as many times as you need to. There's no limit to how many times you can do your test review. So we're going to graph x plus 4y is greater than 8. So you can graph these using whatever method you like. Actually, you can use, so now we know slope-intercept method, slope-intercept form. We know using x and y intercepts. You can make a table of values if you wanted to. The graphing part, that part doesn't change. It's just that now we have inequalities, so your line may be a solid line or a dotted line, and then you want to shade a region because your solution is not just going to be a line, it's going to be like a whole region on the plane. So things to remember: if it's greater than or less than, you use a dotted line. If it's greater than or equal to or less than or equal to, you use a solid line. Okay, so I am going to use, let's use slope-intercept form. So if I use slope-intercept form, I want to get y by itself. So I'm going to subtract x. So I'm going to have 4y is greater than negative x plus 8. And then to get y by itself, I'm going to divide by 4. So y is greater than negative 1 over 4x plus 2. So remember, slope-intercept form, we begin by plotting the y-intercept, which is the b. So I'm going to do that here. So b is 2. So we're going to go to the y-axis and plot 2. Then we're going to move with the slope. The slope here is negative 1 over 4. Okay, so b equals 2, m equals negative 1 over 4. So that means from here, I'm going to go down 1 and to the right 4. So down 1 to the right 4. Then I'm going to make my line. But, hold on, check your inequality. This is greater than. It is not greater than or equal to. So notice over here, this needs to be a dotted line. So you want to graph this like this. What that means is that a point on this actual line is not a part of our solution. But now we need to shade a region because the points are either going to be all up here or all down here. So you can do it a number of ways. If you put your inequality in slope-intercept form, which is what we have here, you can look at the inequality sign. If it's y is greater than, then you would shade above the line. Another way to do it is to use a test point. And I feel like a test point is probably the safest way to do it. So pick a point not on the line. And it's really cool when 0, 0 is not on the line, because that's a really easy point to use. So I'm going to use 0, 0 because it's not on my line. So take this point, plug it into your inequality, and see if you get a true statement. So x is 0 and y is 0. So it's 0 plus 4 times 0, which is greater than 8. So that's 0 plus 0 is greater than 8. So 0 is greater than 8. Is that true? Is 0 greater than 8? Of course it's not greater than 8. That is not true. So that means we do not shade where the test point is because this is not a solution. So we would have to shade on this part of the coordinate plane. So this would be your shaded region. So what that means is that any point inside here would be a solution for this inequality. So that is what your graph looks like. So it's a line. For this one is dotted, and then you have to shade a region to represent all of your possible solutions. Okay? Now let's do one with a solid line. And then any other questions, and we're going to be done for today. Okay, so last problem, number 24. So it's 3x minus y is less than or equal to 6. Okay, so we're going to graph this. I'm going to use intercepts just to be different. So this is a kind of quick way to do it. So if you want to graph it using x and y intercepts. To find the x-intercept, we're going to make y be 0. So that would end up being just 3x minus 0. So let's find the x-intercept. So I'm just using a different method. You could use slope-intercept form, totally okay. So 3x minus 0 is equal to 6. I'm making it an equal sign because I'm just finding intercepts, so the inequality part isn't going to affect my intercepts. So I have 3x equals 6 divided by 3. So x has to equal 2. So my x-intercept is 2. So on my graph, I'm going to go to the x-axis and go to 2 and plot my point. Now let's do the y-intercept. So it's going to be 3 times 0 minus y equals 6. 3 times 0 is 0. Minus y equals 6. So negative y equals 6. So then to get to be positive y, I'm going to divide by negative 1. So y equals negative 6. So I will go to the y-axis and go to negative 6. 1, 2, 3, 4, 5, 6. So I have my 2 points now. Before I start drawing my line, pay attention to the inequality. It's less than or equal to. So we're going to use a solid line. So I'm going to, oh, that was pretty good. Draw my line. Now it's time to shade the region. So let's see, I'm going to use a test point. I'll do it here. And again, my favorite test point is 0, 0. If I can use it. Now, if 0, 0 was actually on the line, I couldn't use it. But it's not on the line, so I can use 0, 0. So let's see if 0, 0 is a solution. If it's not a solution, then my solution is not where 0, 0 is. If 0, 0 is a solution, then this is where all of my solutions are. So 3 times 0 minus 0 is less than or equal to 6. So 3 times 0 is 0, minus 0 is less than or equal to 6. 0 minus 0 is 0, so I have 0 is less than or equal to 6. Is 0 less than or equal to 6? 0 is less than 6, so this is true. Yes, 0 is less than or equal to 6. So since my test point lives here, this is where my solution will be. All of these points here, any point inside of here would be a solution for this inequality. Any point on this side of the line would not be a solution for this inequality. And that is it. So we just went through an entire test review. And your actual test is very similar to this test review. So my advice when it comes to studying for your test is to, of course, start taking the review now. See what you know now. get an idea of what type of problems you need to work on more. And then when you start preparing to take the actual test, you want to, sit down at a computer, because it's going to be on the computer. You're welcome to come down to the depot and do it with no interruptions, no notes. Give yourself 2 full hours and take the test. Put yourself in that testing situation multiple times so that when you are actually in the testing center taking the test, that feeling of being timed, being on a computer, not having notes doesn't feel so scary to you, because that's where that test anxiety comes from when it's a new feeling. So I just strongly encourage you to use this test review as many times to help you prepare. And that's in a testing situation, a simulation, I will say, of a test. And then just to practice over and over again, come to the depot, ask questions, things like that. So if there are no other questions, then we're going to wrap this up. Thanks, guys, for tuning in. If you have any questions later, just email me. You're welcome to come down to the depot and see me or our tutors. And if there's no other questions, I'll see you guys later. Bye.